Hi to all. In this video, we are going to see about output equation of DC machine. Before going to DC machine output equation, why we should go for output equation that we should know. Okay. Here we show the diagram. In this diagram, we have a DC machine. Okay. It's armature and there's a core, armature core. Stator rotor was there. Okay, so the diameter of this one is called D, and the length, this length is called L. Okay, why we are going for output equation? To find the D and L, that is main dimensions of the DC machine, we are going for here output equation. Okay, the size of the DC machine depends upon the main leading dimensions of the machines via diameter of the armature D and armature core length L. Okay, so D and L. Okay, to find these things, we are going for output equation. As output increases, the main dimensions of the machines D and L also increases. Okay, so we are going to find using the output equation the D and L from this equation. Okay, output equation of the main dimensions of DC machines. Okay, output equation relates the output and then main dimensions of the DC machines. Actually, it related to the power developed in the armature and main dimensions. So, some of the things we are going to know. E means EMF induced or back EMF. IA is the armature current. Okay, E induced EMF or back EMF and IA is the armature current. Pi, okay, average flux value of flux per pole. Z, capital Z, total number of armature conductors, and N is the speed in RPM, and capital P, number of poles, A, number of parallel paths, okay, so number of armature paths or circuit, okay, and D, diameter of the armature, L, length of the armature core, power developed, okay, power developed normally in terms of kilowatt. Okay, we are mentioning like that. So P is equal to EI or VI. Here we are mentioning V instead of V, E, IA into the power of minus 3. Okay, so the same equation E value we can write pi is at N P by 60 into A. Okay, so instead of E, we are going to substitute the value of pi is n by 60 into A, and IA, we are substituting the value of IA into the of minus 3. Okay, from that P pi, okay, P pi we are segregating, okay, P pi and IA Z by A multiply with N, okay, and 10 to the power of minus 3. Okay, let us consider this equation number 1. The term P pi represents the total flux and is called the magnetic loading. Okay, there are two types of loadings are present in DC machines as well as AC machines. That is magnetic loading and electric loading. Okay, here the term P pi is nothing but magnetic loading. Okay, the magnetic loadings per unit area of armature surface is called specific magnetic loading or average flux, average value of the flux density in the air gap, BAV. BAV is nothing but average flux density. Okay, BG is nothing but specific magnetic loading. Okay, BAV is equal to P pi by pi dl Webers per meter square or Tesla denoted by T. Okay, therefore P pi is equal to, okay, BAV pi dl, where in this equation P pi is there, that we have to replace P pi with BAV pi dl. Okay, why we are going to replace this one? We should know, or we should find the values of main dimensions of the machine like D and L. D is the diameter of the armature and L is the length of the armature. Okay, to find the things, to find that values, we are going to substitute the value of P pi is equal to BAV pi dl. Okay, B pi is equal to BAV pi dl into that this equation. Okay, So the term IAZ by A. Here IAZ by A is there. Okay, instead of this one, what you are going to replace? Okay, the term IAZ by A represents the total ampere conductors on the armature and is called electric loading. I told no, there are two loadings are present for every machine. One is magnetic loading, another is electrical loading. Okay, here the IAZ by Z. IA is the armature current, Z is the number of conductors, and A is the parallel paths. Okay, so IA Z by A represent the total ampere conductors on armature and is called the electric loading. Okay, so electric loading per unit length of armature periphery is called specific electric loading Q. Okay, that is Q is equal to IAZ by A pi D ampere conductors per meter. So IAZ by A is equal to Q into pi D. Okay, if you simplify this equation, we will get IAZ by A is equal to Q into pi D. Let us consider as equation 3. Okay, and substitution of equation 2 and 3. This is a second equation and this is a third equation. We are going to substitute these two equations in this equation. Okay, what we got? Okay, so therefore substitution of equation 2 and 3 in 1 leads to Kw is a power. Okay, BAV pi dl Q pi d into n into 10 to the power of minus 3 by 60, or we can rewrite 1.64 into 10 to the power of minus 4 BAV Q d square Ln. Okay, so here some of the terms we should consider as a coefficient of DC machine output equation. So where C0 is C0 d square Ln. Okay, is the final output equation of the DC machine. Here C0 is the coefficient of the output coefficient of the DC machine, and is equal to 1.64 into the power of minus 4 BAV into Q. Okay, so therefore d square L, we are going to find the values of d square L or d and L. Okay, that's the main aim of making this output equation, to find the values of length and dia of the armature of the specific machines. Okay, DC machine. For the purpose, we are going for these output equations. Okay, so therefore d square L is equal to Kw divided by 1.64 multiplied with 10 to the power of minus 4 BAV Q into N meter cube. Okay, where C0 is called output coefficient of the DC machine and is equal to 1.64 into 10 to the power of minus 4 BQ. Okay, therefore d square L d square L is equal to Kw divided by 1.64 into 10 to the power of minus 4 BQN meter cube. This is the output equation. The above equation is called the output equation. The d square L product represents the size of the machine or volume of iron used, in order that the maximum output is obtained per kilogram of iron used. D square L product must be less as possible. For this, the value of Q and VAV must be high. Okay, so the value of specific electric loading and specific magnetic loading value, if we increase the value of specific magnetic loading and specific electric loading, then the length of the machine and diameter of the machine will be reduced. When the diameter of the machine and length of the machine will be reduced, the cost of the machine itself reduced. So the output equation is used to find the value of D and L, diameter of the armature and length of the armature. Okay, from that we can easily identify how much the iron used, how much copper is used for a particular machine. To reduce that, we should increase the value of that specific magnetic loading and specific electric loading of the machine. Okay, so output equation is, so d square L is equal to Kw divided by 1.64 into 10 to the power of minus 4 BAV Q into N meter cube. Okay.